Yep. So we are simplifying square roots, but they're going to have variables inside. There is an extension to this lesson. I know I do it in Algebra 2 a little bit, but I don't know if I'm supposed to do it in Algebra 1. I should know since I teach the class, but I need to look a little bit closer. We wouldn't have done it today anyways, because today we'll just do square roots, but you can extend this lesson into cube roots and fourth roots and fifth roots. But I don't know how much of that we do. Anyways, for today, they will specifically only be square roots, and there will be letters inside, variables inside. Okie dokie. It's really not difficult at all. So let's start with a conversation about, like, basically, if you know the answer to this question, then you understand what a square root is. And so let's ask this one. Do you know what the square root of x squared is? And again, it really hits at the heart of, do you truly understand what a square root is? I'll give it a shot. It's x. It's just x. If you think about it, I'm asking the question, when I say this math problem over here, I'm asking the question, what would you have to square to make what's inside? That's what the concept of a square root has always been about. Like if I say, what's the square root of 100? I'm simply translated asking you, what number would you have to square to make 100, which is why the answer is 10, right? So if you understand that question, then you understand logically that the square root of x squared is just x, right? So let's extend that a little bit further, and let's then take it another step and say, what is the square root of x to the 4th? The question again becomes, what would you have to square to get what's inside? Yep. Let's take it a step further. What is the square root of x to the 6th? The question really is, and I'm going to write it in, we'll do green over here off to the side. The question is, what would you have to square to get what's inside x to the 6th? What would you have to square to get x to the 6th? X to the 3rd, because we know our properties of exponents. We know that I would multiply, so I'm looking for something that when multiplied by 2 makes 6. So the square root of x to the 6th is x to the 3rd. It's at this point where we would assume you would observe a pattern starting to emerge. You see a pattern starting to emerge, I would assume, at this point. So if I had another level of this x to the 8th, what would you say it is? X to the 4th. Again, if you haven't seen the pattern yet, well, I would say I'll just keep going until you do. And at some point, if I go to a certain point and you still haven't seen it, I might have to check you for a pulse, perhaps. What is the square root of x to the 10th? X to the 5th. Good. I could go, and I could go all the way until you understand, like, what is x to the 240th? It's x to the 120th. A lot of times in math, we can take simple, small, manageable examples that we can actually see, and we can just extend them to any level that we want. What you figured out after probably a couple iterations of this process is I just have to take half of the exponent. So if the original exponent inside is 2, half of 2 is 1. Original inside is 4, half of 4 is 2. Half of 8 is 4, so on and so forth. So are you okay with that portion of this? This logic only works for square roots. It would not work if we were doing cube roots or fourth roots, which is why I say there's a whole nother extension to this lesson if the index of these roots changes. So what I'm talking about right now is if these roots over here, don't write this down, were like cube roots or fourth roots or fifth roots, then what we have on the board would be a lie. Okay? So square roots, we essentially divide the exponents by 2. Which, of course, now begs a very, very, very simple and logical and necessary question. What happens if you can't divide the exponent by 2? You know how if we take a square root like 45, can you take the square root of 45 and get a nice answer? No. But do we have a strategy for that? Yeah, we do. And we should, and there's a reason I had you practice 130 of these. And that's because by now you should identify the number 45 as built of a 9 and a 5, right? So if I were to take the 45 and break it up into the square root of 9 times 5. Notice the 9 is red. What is the square root of 9? It is. So I would write this as 3 root 5. What I've essentially done over and over again, and I say I mean you guys, we have learned that I take a number and I break it into a good part, the best possible good part, and then the necessary leftover bad part. Good guy, bad guy, good guy, bad guy. So I can think the same way when I look at x to the 11th. I can break it up into 2 pieces, one of which is good. What's the biggest number you can get out of 11 that you can divide by 2? Nope. I heard someone whisper something. Nope. Just think about x to the 11th and ask yourself, if I were to break it into 2 pieces, some x is here, some x is here, what's the biggest one I could put in the first spot that we just learned I can actually take the square root? 9's no good. 10 is great. If I took my x to the 11th and I broke it into, put 10 of them here and 1 of them here, problem solved, right? It's that same exact thing. Look at the problem just over to its right on the TV. If I can take the number 45 and break it into a good part and a bad part, I can do the same for a bad x. I can take that bad x and I can milk as much out of it as possible. The most you can get out of 11 is 10, right? And now what is the square root of x to the 10th? You just learned this. It is x to the 5th. And then this guy, I'm going to use a yellow arrow to show you that guy was not able to break out of jail. So we're going to keep seeing this, that we break these variables with exponents into good guy, bad guy. We take the biggest possible good guy, square rooted to freedom, and then we leave the necessary leftover bad guy. Okay? There's about a 16% chance that you fully understood all that. So let's do another one and get that up to like 50%. So once again, here is a bad guy. Y to the 43rd is no bueno, right? Because 43 is odd, and you learn back in like 3rd or 4th grade that you can't divide odd numbers by 2. Not and expect good whole number results, right? So what's the biggest package deal you can get out of a 43? Think of a number that's really close to 43 that you can divide by 2. 42. If I take the 42 pieces, think of y to the 43rd as just a boatload of y's, 43 y's stacked side by side by side by side. If I reach my arms in and I collect 42 of them and set them down, I've made a good guy. I've made something that I can square root. How many y's will be left over, though? How many don't make the cut? Always that 1. It's a really basic number theory idea that if you can't divide a number by 2, you can get really close. You can change that number into something really close. What is the square root of y to the 42nd power? Again, you're not trying to take the square root of 42. What's half of 42? Therefore, we can pull out y to the 21, leaving behind this guy. I refer to these as jailbreaks. It's always felt so visually appropriate to me. Just it feels like the right thing to say that that guy broke out of jail, right? We set him up in such a way that he could break out to freedom and move on with his life. But this poor y to the 1, he's like, I couldn't get out. I'm stuck here. Let's go again. M to the 9th is no good. But we could get really close up to y to the, or m to the 9th, right? What would we break m to the 9th into? M to the 8th. The sound of your voices tells me that that clicked that time. I heard a lot of voices saying that. I get as close as I can to that stupid odd number from the bottom side. I can't go above it, obviously, because I can't take something that's not there. But I can take 8 out of 9, leaving 1. And what's the square root of m to the 8th? Good. Are we feeling like yes? Wonderful. Now let's put it all together and let's put numbers and letters inside the same square root signs. So let's do the square root of 140 m to the 11th times n to the 12th. Do you see any good guys inside the square root?
Wow.
I agree. The end of the 12th is a good guy, but he's the only one. So I look at this and say 140, I'm going to need to work with you. And m to the 11th, I'm going to need to work with you. But n to the 12th might as well have been written in red. He's going to break out of jail without any sort of fancy stuff, unless you can't divide things by 2, in which case you got a rough road ahead, right? So I look at the end of the 12th and say, you're fine. I'm going to deal with you in a second, but I got to go to those purple and green guys. They're no bueno. Now, all the practice we've done should enable us as a class to figure out how do we take the purple number, the 140, and break it up into 2 pieces, one of them being a jailbreakable and one of them not being. And notice the size of that square root sign. It's like, what are you doing there? We need some room. So does anyone know how to break down the number 140? This is what if you haven't done all 130 practice problems, you should get them done. How do you break down a 140? And I am just going to sit here until you guys figure it out. So the quicker you grab your calculators and get going, the quicker we'll get through this. I'm not going to work it. I could have just started you something easy like 8, all right, 27, but I thought, no, let's just go. Let's go. 70 times 2 is pretty rad, but it does me no good because 70 and 2 are neither of them are on the red list. Remember. Again, awesome work finding numbers that make 140, but 28 and 5 are not on the red list. Therefore, it's no good to me. It's dead to me. I need a combination of 2 numbers that multiply to make 140. One of them has to be on the red list. And I'd prefer, please, that the one that's not on the red list, we are sure is a dead root. Well, it makes 140. Again, for 3 times in a row, I'll say kudos to you. You're finding lots of numbers that make 140. 4 and 35 is the only one so far that has piqued my interest at all. Thank you for finally saying something that's on the red list. If I do 4 times 35, is 35 going to be a dead root? I see Jesse nodding his head, and I agree with him. 35 is not a prime number, but it is a root that is not simplifiable. What are the only factors of 35? 7 and 5, which are dead to me. Therefore, 35 is a satisfactorily dead root, which means 4 times 35 is our only / best choice. So what I'm going to do, and I'm going to color code this for you, is I'm going to take the number 140, and inside the root, I'm going to rewrite it as 4 times 35. Good guy, bad guy. So the purple number is dealt with. Now we have to go to the one that I've underlined in green. We all agree from the first 10 minutes of this lesson that m to the 11th is no bueno, right? But we practiced and practiced and practiced this at the beginning of class. How do you break down an m to the 11th into good guy, bad guy? You put m to the 10th times the inevitable leftover m. And then, of course, we have our n to the 12th, which was a good guy from the get-go. When you look at my television or your page, somehow you have to find a way, because I use colors, you probably don't, find a way to identify good guys, bad guys. One trick I've had people use in the past is they write them in white like this, because, well, in your case, like you just write them and they all look the same with the lead of a pencil. And one identifier you can use is to circle the good guys. Unless you're someone who uses colors, then you're set. But like I could circle the 4, circle the M, and circle the N. That's my way of saying those are the guys that are about to become jailbreaks. Follow? So when 4 jailbreaks, what does he become? Good. When M to the 10th jailbreaks, what does he become? And when N to the 12th jailbreaks, what does he become? Good. So what we're going to see at the end of this problem is a collection of jailbreaks and inmates, right? Things that are stuck, lifers. So when the 4 breaks out, he becomes 2. When the M breaks out, he becomes M to the 5th. And when the N breaks out, he becomes N to the 6th, leaving us with a square root of who's still inside, who was unable to break out? 35M. This is what a nice simplified root should look like. Some things break out, some things don't. It's not our fault. We can only do what we can do. That one feel okay? Nice. Next one. Let's do -4 times the square root of 200 x to the 15th y to the 21st. You notice there's already a jailbreak, right? And we had a little conversation one day. It didn't take but 5 minutes to talk about what do you do with an existing jailbreak? You just let him hang out, and eventually he's going to multiply by another jailbreak, assuming that there is one. So the -4 is just going to kind of go off to the side and maybe check his emails or something and just wait while we deal with the root. Do you see any good guys inside the root? Any that are just ready to break out? I apologize on behalf of those kids in the hall. They should know better. So let's keep going. You see any guys inside the root that are just perfect and ready? 200 is not a good guy. Say again? Nope. 21 is an odd number, therefore we cannot break him out. Anything else? I see no good guys at all, which means that the 200, the x to the 15th, and the y to the 21st are all going to get broken into good guy, bad guy. So we're going to need room here in just a second for 6 things. So we need to make, you can put your -4 down if you want, or just put it on timeout. It doesn't matter. And then make a nice, super long square root sign. So here we go, one by one. And I'll put little colors up here so that you can see what I'm referring to. So let's start with Mr. Purple. You practiced and practiced and practiced and practiced and practiced. You should know this one. How do you divvy up a 200? 100 times 2. And I'm always going to say the red list number first, right? I want the order always to be good guy, bad guy. Always, always, always. And so I'm going to break it up into, and I'm going to use my colors, 100 times 2. I put 100 in red because it's a red list, and I know it's the best red list because 2 is trash. On we go to the x. What's the best we can do to break up that x to the 15th? X to the 14th times the inevitable leftover x. And how do we break up the y to the 21? Y to the 20th times y. Looking at that square root sign a minute ago, we thought that thing's way too long, and look at that, we maxed it. So now I've got good guys, bad guys, in my case color-coded, in your case maybe circled or something to identify. It's really important that you identify the good guys because now they're all going to break out of jail. So here we go. When 100 jailbreaks, what does he become? What about the x? X to the 7th. And what about the Y? Y to the 10th. Nope, it's done. Once you take half of it and break it out of jail, you don't keep pounding on it. Like you can do it, you can root something once and then it's done. Okay, you can't keep attacking the same number. So let's think about this. If that 100 flies out and becomes a 10, and then it multiplies by that -4, what do we get? We sure do. That jailbreak, that pre-existing jailbreak, was just waiting for his homie, and then he flew out of jail and they multiplied up and made a big number. How many X's will we have outside again? X to the 7th. How many Y's will we have outside? Y to the 10th. And then who is a lifer who's stuck in jail? 2, X, and Y. If you ever look inside the jail after you're done and see something that can break out, you can keep going. It just means you made a poor choice at some point along the way. It means you didn't break something up correctly or efficiently. Okay. How about this one? Let's do 6 times the square root of 400 m to the 10th y to the 24th. You see any good guys inside the jail? I like that m to the 10th. I like the y to the 24th. Mila? I like the 400 also. I wanted to make sure you understand that your answer won't always have to have a root. Think about like if I asked you for the square root of 9, you wouldn't make a dumb tree. You would just put 3, right? Well, this is the same idea. 400 is a jailbreak waiting to happen. M to the 10th is a jailbreak waiting to happen, as is no modification necessary. Everyone's going to free themselves out. What is the square root of 400? It is 20. And what is 6 times that 20 that's flying out? So we have 120. Nice. If you ask, why am I not breaking things up? You're just not paying attention, because I don't have to. You only break things up if it's not already a good guy, right? These are all good guys. What does m to the 10th shoot out and become? What does y to the 24th shoot out and become? Just like that. And our answer is done. No need for a root because everyone busted out of jail. It was like a big mass breakout, right? Then the last thing I wanted you to see, and then I'll let you work now, is something like -8 times the square root of 32xy. We all agree that there are no good guys inside the root, right? 32 is not a good guy. X is not a good guy. Y is not a good guy. So we've got some work to do. So let's talk about breaking things up. Let's leave the -8 outside in timeout. And let's put a little bit of room in here. I don't need a very long square root this time because X and Y cannot be broken, right? So the number 32 can be broken down, right? We agree. We've practiced this enough. We're not going to make some rookie mistake and say 4 times 8. Who do we recognize 32 to be? Yeah, you should have seen this number probably a half a dozen times by now. He is 16 and 2, right? So I'm going to take the 32 and I'm going to break it into good guy of 16, bad guy of 2. Don't be a rookie and use 4 times 8. We know better. That's why we practice. How can I break up my X? I can't, right? He doesn't have anything to offer. Basically, you're looking for packs of 2. And X to the 1 is like, I don't even have a single 2-pack in there. So you can't have any. So we just leave X and we leave Y alone. I wanted you to see that not always is there progress to be made. If you're left with something that's just bare bones, you can't do anything. Again, you play the cards you're dealt. And in this case, we got nothing. But there is one jailbreak. It's that 16. And when he breaks out, what's he going to become? He's going to become a 4. And when he multiplies by the other jailbreak, what do they make? We get -32. And then who's stuck in jail? The 2, the X, and the Y. Done. You feel like you got this? Hey, I didn't remember to put assignment number 55 on the paper. I had already run copies of it. So I'm gonna need you when I hand it out, at the top, it just says assignment. So you just need to put number 55, just so we can identify it and keep track of it, okay? All right, I'll leave the recording going. I'll just pause it.